Mollie Minsel, Senior Sales Representative of VI Grade, here today interviewing Greg Stevens, Director at Mcity. Greg?
Thanks for having me, Molly. I appreciate it. So a little bit on my background. So Mcity is my second career in academia. My first career was at Ford Motor Company, where I worked for 34 years, actually. It was a great career. I enjoyed it immensely, learned a lot of good things, ended up chief engineer for the driver assistance features. So I got to work on all the really great features like Blue Cruise, where you can take your hands off the wheel on the freeway, all the trailering, pro trailer backup and auto hitch to help you, move trailers around, parking features, collision avoidance features. So, it was really a fabulous experience that then set me up well for this job, now moving to academia at the University of Michigan, because I can bring that industry background and use it in my role as research director at Mcity to shape the research agenda that we have.
So the University of Michigan's College of Engineering, Mcity is a division of that sector?
Yeah, that's right. Okay. We're a center within that. The best way to think of Mcity, most people when they think of Mcity, they think of it's a test track, a physical test track on North Campus in Ann Arbor that looks like a mini city, right? And that is, 10 years ago when it was created, that was its sole purpose, and it was very novel at the time. It was the first of its kind. But now we're evolving it actually with some great sponsorship from the National Science Foundation. We're evolving it into a physical proving ground for testing autonomous vehicles like we've done for a decade, but on top of that, we're putting a full digital twin. So the really cool thing that we can do with that is we can have the physical autonomous vehicle driving around the track, seeing everything it sees, but we can also have it driving simultaneously in the digital world, and we can insert objects that it will then see. The physical vehicle on the track will see these objects that only exist in the virtual world. And so that's a real upgrade that we've recently introduced at Mcity.
Excellent, congratulations.
Thank you.
On the topic of sponsorship, we're here to talk about VI Grade and Mcity's relationship. So let's get into the questions. What is Mcity's role in supporting the automotive industry, and what are the key activities in advancing mobility innovation?
If you're somebody in the mobility space and you have a really good idea for a technology that you want to try out, and you're at that very early stage, then you should think of Mcity as the place you can go to get all the tools you need in order to take your idea and make it at least the first level working prototype of that idea, right? So we have the physical track, we have autonomous vehicles, we have drones, we have the VI Grade simulator, which is right there at the track. Like I said, the full digital twin. We have what we call an orchestrator of adversity, basically that looks at the autonomous vehicle as it's driving around and puts obstacles in its way, basically, to make it harder to stress test the autonomous vehicle. So we have all those things in our toolkit, and we have a full data engine for creating AI algorithms and a compute cluster of GPUs. So we have the toolkit to take your idea and make it real, and that's one of the main services we provide.
Excellent. On the topic of automotive, Greg, how does VI Grade simulation technology support Mcity's mission to provide a safe, controlled environment for companies developing autonomous and software-defined vehicles?
Yeah, so early on in my career, I remember somebody told me that test tracks are a safe place to do unsafe things, right? And I've always felt the same way about simulation. It's all in the digital world, so nobody can get hurt. And the nice thing about a simulator is that it allows you to physically experience your simulation model. You get to drive it around and see how it behaves. And people are really good at giving subjective feedback, like I like it, I don't like it, it scares me, it makes me comfortable, those kind of things. which are hard to get just from looking at data when you look at a simulation model, right? So that ability to experience your model and see how it performs, I think, is a real advantage of simulators. Anytime there's a human in the loop in, operating the feature, I think it's very useful. And the other thing I really like is the ability to change scenarios really quickly, right? Like you can go from, a daytime drive on the track to nighttime in the rain with really poor visibility, right? You can do that right on the fly in a simulator, which is a real advantage.
Absolutely. So between safety and vehicle dynamics, there's a lot of opportunity there to expand.
Yep.
How do you integrate VI grade simulators into your testing process to replicate real world edge cases that are difficult or unsafe to test physically?
Yeah, so let me tell you about one that we're doing right now. We're putting it together for the fall term for a group of students to do as a student project. And it's on a feature that's what's called level 3 autonomy. And so what SAE level 3 means is that the driver's driving the vehicle and the vehicle senses that now is a time that the vehicle could take over control. So the driver engages the feature, and then they can do whatever they want. They can take their eyes off the road. They can watch a movie on an iPad if they want. They can text. But they have to remain re-engageable. And that's the real human factors thing that's tricky is, how do you handle those re-engagements in some of these risky scenarios? So there's an example that we saw that Waymo actually published. It was from their driving videos where the Waymo vehicle was driving and a pickup truck in front of it accidentally dropped a gas grill out onto the road that came right into the path of the Waymo vehicle. So that's a level 4 vehicle, so it had to autonomously avoid it. But say that was a level 3 vehicle where the driver still has to be re-engageable. What's going to happen in that situation? Think about it, say the driver's watching a movie on their iPad, and then all of a sudden, the vehicle's going to see that gas grill and it's going to start braking and it's going to start steering and it's going to tell the driver to re-engage. And how do you handle that, right? How does the driver look up, see what's going on? Do they grab the steering wheel and panic and make it worse? Do they just leave their hands off and let the vehicle handle it all on its own? Those I think are really important human factors questions that we need to look at. And the simulator is the only place you can do that, in my mind, because dropping a gas grill in front of a vehicle is not something you want to do in the real world, right? You want that to be a virtual gas grill in a digital world when you're doing that testing. So it's going to be a really great student project that we're going to run. The students are actually going to be designing the instrumentation cluster and the center stack and all the warning strategies to do the re-engagement. So it should be a really cool learning experience for them.
Great. Yes, indeed. We look forward to the updates on that project.
Yeah.
What are the key benefits of simulation in complementing real-world testing and accelerating the transition to software-driven mobility solutions?
Yeah, so at Mcity, we talk about a thing called the curse of rarity a lot. And what that basically means is, it's really easy to get your autonomous vehicle to operate well in normal conditions, but it's really hard for you to get it to operate really well in these rare sort of edge case conditions. So that's the curse of rarity, is that as you get to these rare edge case conditions, they're harder and harder to find. Like, for instance, humans go about 500,000 miles between accidents, right? And then if you're talking about fatal accidents, it's 100 million miles. So, you really can't do that with physical driving. You have to do that with simulation. And so that's why we're really focused on that at Mcity, is creating, a simulation environment that's trustworthy, right? And to do that, you have to, really work on the sim to real gaps, right? And the ones specifically we're taking on are, making our digital twin as high fidelity as possible, creating behavioral models of the other traffic participants, whether they're vehicles or pedestrians or scooters around the vehicle, and then also models of the sensors themselves so that we get really good high-fidelity physics-based sensor data. And we think if we really move the needle on those three, we'll do a lot to address the sim-to-real gaps and make a really strong case for simulation as a great safety assessment tool to try and find all those rare edge cases.
Yes, that well defines the breadth and the depth. How do AI and machine learning enhance simulation-based vehicle testing? And how does Mcity leverage these technologies for future mobility research?
Yeah, so in the AV space, AI has been just a complete game changer. I mean, the vehicles are driving dramatically better with AI algorithms than previously with sort of hand-coded, algorithms that we wrote in C++. And then as we move to end-to-end algorithms, they seem to be getting even better. But there's a difficulty, which is that these AI algorithms, these AI models are black boxes, right? We can't open them up and read them like we could do with, C++ code. So when an AI model fails in our testing, we can't actually say why. It's not like you can go find the line of code where the error was and fix that line and then send it out, right? You have to get training data, retrain the model, and hope that you did enough training in that specific case that the AI model learns not to make that same mistake again. But it's hard to give, guarantees of that. And so, AI is critical. We can't do autonomous driving without AI, but it really actually amps up the need for more and more testing because of the fact that it's a black box. We need to test it more to make sure that it's behaving the way we want it to behave.
This is really exciting innovation for both academia and automotive collectively. Greg, thank you so much for being here today. I'm sure that you've captivated the audience and they're going to want to learn more about your initiatives at Mcity. How can they find more information? Do you have a YouTube channel or LinkedIn? What are some of the handles that we could find more about Mcity?
Yeah, Mcity, we have a main website, if you Google Mcity, and we also have a YouTube channel, and we have a LinkedIn page as well. So we try to be very transparent in what we're doing. A lot of our work is released open source. Our digital twin is open source. Our AI data engine is open source. That orchestrator of adversity I talked about is also open source. So, we try to be very transparent in sharing in the work we do to try and, move the mobility space forward.
Excellent. Thank you so much for being here today. I appreciate your time, and we look forward to what's next.
Thanks, Molly.
You're welcome.